Okay, so we've already gone over how to solve a quadratic inequality. So we've learned the method. What we're trying to do right now is we're just trying to get some questions in to cement this idea. Now we go over here at the first problem, and we basically got this quadratic expression and an inequality, and then it says solve the inequality. So since it's basically quadratic because it has that square and it has that inequality sign, we know that we basically got to apply the quadratic inequality method onto this. And that's what we're going to do. So this is going to be 4x squared minus 12x is greater than 7. Now first of all, let's get a 0 on this side because that's what we do. So 4x squared minus 12x is going to be minus 7 greater than 0. Now this is in the form we want it to be in. Therefore, we can now just go and apply our method. So the first thing we're going to do is we're going to factorize this. And I'm basically going to use middle term break over here. I hope you guys know how to do that. So 4 times negative 7 is negative 28. And our two numbers are going to be negative 14 and positive 2. Right? We've done this a lot of times, so I'm not going to go over what I'm doing right now. But I hope you know how to do middle term break. So it's going to be 4x squared minus 14x plus 2x minus 7 is greater than 0. And I can take my commons. It's going to be 2x. And then I can take a plus 1 common over here. So I'll be left with 2x minus 7. Okay, now we go on to step number 2, which is to use a number line. And so we use these two factors that we found out to basically find the points of interest on our number line. So we put 2x plus 1 equal to 0, and we solve it out to get negative 0.5. And then, negative 0.5, or you can say it's going to be negative 1 by 2, same thing. And then we can put 2x minus 7 equal to 0, solve it out, so we're going to get 7 over 2, which is also 3.5 in decimals. So we got 3.5 over here, and we got negative 0.5 over here. Now we're just going to test out these sections. So we got this section, this section, and this section. So let's check out the middle section first. So we can take anything between negative 0.5 and 3.5. I'm going to pick up 0, and I'm going to test it in this factorized form up here. You can go ahead and test it in this form over here as well. And this is the standard form, this is the factorized form. Actually, let's just use the standard form for this. So we got 4x squared minus 12x minus 7 is greater than 0. We put a 0 in here, and all of this becomes 0. You put a 0 over here, all of this becomes 0. So it basically says negative 7 is greater than 0, and we know this is not correct. So big cross on this section. Now we're going to basically go for the first section, which is this thing right over here, this region, and we can pick a value, let's say negative 1, because that's smaller than negative 0.5. And I'm going to put it in my factorized form, so 2 minus 1 plus 1, and 2 minus 1 minus 7 is greater than 0. We can solve this out. So this would be negative 2 positive 1, and negative 2 negative 7. So negative 2 positive 1 would just give us negative 1, and negative 2 negative 7 would give us negative 9. You multiply this, you get positive 9 is greater than 0, and this is correct. So we put a check mark on this section. And now we finally got this section right over here, so we can pick a value. Let's say we pick up 4. And we just go ahead, we put the 4 in here. So I'm going to put a 4 in here, a 4 in here, and I'm going to solve this out. So 2 times 4 is going to be 8. 8 plus 1 is going to be 9. And then we're going to get 1 over here. You multiply this, you get 9 is greater than 0, which is true. So we got this section over here. So we got two sections, anything that is smaller than negative 0.5 and anything that is greater than positive 3.5. So we can go ahead and say that x is greater than 3.5. And x is smaller than negative 0.5. Now for the next problem, we're basically given a quadratic expression and it's put equal to y. And it says find the set of values for x for which y is greater than 13. So we have this thing, we have y is greater than 13, but we're supposed to find values of x. Okay, now if you look at this thing, this clearly doesn't have an x. So how do we get an x in here? Well, we know what y is equal to because they've already given us an equation. They've said y is equal to this thing over here. So we're just going to substitute this thing, and it's going to be 2x squared minus 6x plus 5 is greater than 13. And now you can see it's a quadratic inequality because it has that square up there and it has an inequality sign. So let's bring this 13 over there to this side and get a 0. So this is going to be 2x squared minus 6x minus 8 is greater than 0. Now we got to factorize because it's an inequality, and we're just going to use the inequality method to solve this out. So 2 times negative 8 is going to be negative 16, and then our two numbers could be negative 8 and positive 2. So 2x squared will be minus 8x plus 2x minus 8 is greater than 0. We start taking out commons, so 2x, and you'll be left with x minus 4. And then you can take a 2 common out here, so you'll be left with x minus 4. And now for the second step, you got to use the number line. So you got to use the number line. And you can use these two factors, so put them equal to 0. And you'll get positive 4, and you'll get negative 1. So you draw a number line, put the 2 points on there, which is negative 1 and positive 4. And then you got these three sections, so you're going to check them out one by one. So let's check out the middle section first, and one value we can use from here would be 0 because that's between negative 1 and positive 4. And I can use my standard form to check that out. So this thing is going to be 0, this thing is going to be 0, and I'm going to be left with negative 8 is greater than 0. I know that's not correct, so I just put a cross on here. And then I got this section, so I can pick up negative 2 from over here, because that's smaller than negative 1. And I can put that in my factorized form. So I got 2 times negative 2 plus 2, and then negative 2, negative 4 is greater than 0. I can solve this out. I'll be left with negative 4, positive 2, and over here I'm going to be left with negative 6. So this is going to be negative 2 times negative 6 is greater than 0, and this is going to be positive 12. So this is true. We can go ahead and put a check mark on there. And then we do the same step for that third section over there. And let's say we pick a value, let's call it 5. Put that in the factorized form. We get 1 from here, and then we get 12 from here. So 12 is greater than 0, this is true. We put a check mark on here, and the two values we get are going to be x is smaller than negative 1, and x is greater than positive 4. Now for this next part, they've given us this equation, and it said find the set of values for k for which the equation has distinct real roots. Now before solving this, we can actually go ahead and look at this equation. So this is in the form ax squared plus bx plus c, except we don't have a value for c, we're just given this constant k, and we don't have a value for b, we're just given this b as 3k. So b is basically 3k, and c is equal to k, and then a is 2. And they say find the set of values for k. So this is basically k. We need to find values for this k, for which this equation, this entire equation that we have over here, is going to have distinct real roots. And what does it mean to have distinct real roots? Well, in the previous video, namely the one about discriminants and quadratic formula, I mentioned that distinct real roots are basically another way of saying two roots. And unique real roots, or this can also be said as unique, so distinct or unique real roots. And you can, if they say that you have repeated real roots, that basically means they're asking for one root. So over here they say that, okay, we need an equation that is going to have two roots, and for this situation we have to find the values for k. So what does it mean to have a situation where you got two roots? So we basically talked about this in that same discriminant video where I basically explained the quadratic formula, which was minus b plus minus square root b squared minus 4ac over 2a. Now all of this thing is going to solve out and give us a number. Now the thing is, this number cannot be negative. Why? Because it's under a square root. So you can't square root a negative number. That's not possible. So if this happens, you're basically going to get no roots. So if you need two roots, this thing basically has to be a positive number, because then it's going to solve out, give you two answers, right? There's a plus sign and a minus sign, so it's going to give you an answer for the plus sign, and it's going to give you an answer for the minus sign. That's going to be your two roots. And if this number is just 0, then it doesn't matter, because you're just going to get plus 0 and minus 0, so that just means having no answers. So in this situation, they're basically asking us to have two roots. So we know that the discriminant has to be positive. So how do we say that the discriminant is positive? Well, we say that the discriminant has to be greater than 0, because all values that are greater than 0 are positive numbers. And then we just put the discriminant over here, which is b squared minus 4ac. Okay, so now what we got to do is we basically just got to put the values in here for b, for a, and c. So remember, again, why are we doing this? Well, this is because this is a situation where we will have two roots for our equation. So what's b? B was 3k, so we're just going to put that in there. Okay, and a was 2, and then c was k. And all of this is greater than 0. So now we just got to solve this out. This is going to be 9k squared minus 8k is greater than 0. And now you can see this is an inequality, right? Because it has an inequality sign. And the thing is, it's a quadratic inequality, because this is a constant, this is a constant, and this constant has a square on top of it. So it's almost like instead of having x squared plus bx plus c, you now have ak squared plus bk plus c. And your c, since you don't have a c, you can say that's almost 0. So it's an inequality, but it's a quadratic inequality, and you cannot just solve it like you would usually solve your inequalities. So you need to obviously apply the method for the quadratic inequalities to solve this. So the first thing you want to do is you want to factorize. Now, since we don't have a c term, we don't have to middle term break on this, because we don't have a c term. Usually we have a c term, and so we need to apply middle term break. But we don't have a c term, right? The c is just 0. It's basically this thing is basically this thing, right? So we don't have a c. So we don't really need to apply the middle term break if we don't have the c term. So we can just start taking out commons. So the common over here is k, and it's the k over there as well. So we can just take that out common. So it's going to be 9k minus 8. And we can't simplify it further than this. Usually we apply middle term break and we get those two brackets. But I mean, you get two brackets over here as well. If you think this is a bracket, then you can just write it as, since k is being multiplied to this thing, you can basically write k as k plus 0. And that can be another factor if you like it to be this way, but this is also correct, right? And all of this is greater than 0. So the second step is to basically use a number line. Use a number line. So we put this thing equal to 0 and put this thing equal to 0. 9k minus 8 equal to 0. Right, or if you wanted it to be like this, you could have written this. So you could have written k plus 0 is equal to 0. It's up to you. I mean, in either way, k is going to be equal to 0. So it doesn't even matter. Well, you can send the 8 over there, so you're going to get positive 8, and then it's going to be 8 by 9. In decimals, this is basically equal to 0.88888, and it just keeps on going on. So you draw the number line, you put your 2 points on there, You put a point over here, you put a point over here, so this is going to be 0. This is going to 8 by 9, which is basically equal to 0.888, a lot of 8s. And what you want to do is you want to check out these 3 sections. So if you look at this section, we can pick up a value, let's say -1, because that's less than 0. And I can basically go ahead and test it out in my factorized form. So I'm going to have -1, 9 times -1 minus 8 greater than 0. So it's going to be -1, -9, -8. Okay, and I'm going to get -9, -1, -17 from here. All of this has to be greater than 0. So you multiply -1 with -17, you get +17, and it's greater than 0. We know that this is correct. So you put a check mark over here. Now what you want to do is now you want to go over to the second region and you want to pick up a value from there. And I can just pick up not 1 because I need to pick up a value between 0 and 0.888. And maybe I can pick something that's between them, so 0.5. That's going to work. So I can go ahead and put that back in my equation. So that's going to be 0.5, the 0.5 up there. So this is basically going to be 0.5 multiplied by, this is 9 multiplied by 0.5 is basically half of 9, which is 4.5, and then minus 8. So this is going to be 0.5, and 4.5 minus 8 is going to give you -3.5. And then if you have that number, then you're basically going to get -1.75. So is -1.75 greater than 0? It's not, because it's a negative number. So you put a cross over here. So now we basically move over to our last section, and I can pick a value. Let's say I pick 1, because 1 is clearly greater than 0.888, or 8 over 9. So if I chuck in my 1 into the equation, this is basically going to be 1. All of this is going to solve out to give me 1. And is 1 greater than 0? Well, yes, it is. So you put a check mark on there. So the two values that you have are basically greater than 8 by 9 and smaller than 0. And you're not going to say x is greater than 8 over 9 and x is greater than 0, because this would be incorrect. Remember, the equation, the quadratic inequality we were solving over here and over here, this was not in terms of x, but it was in terms of k. So this k has to be greater than 8 over 9. This k has to be greater than 8 over 9, and this k has to be less than 0. These are the set of values. Now, why does it say the set of values? If you go over there to the question, it says set of values. And there's a reason, because k doesn't have a fixed value, right? It can be anything smaller than 0. Let's say -1, -10, -1000. It can be anything greater than 8 by 9. So it can be 2, can be 400, can be 2000. All of those values until positive infinity, until negative infinity, you can take anything. Anything you can pick up for k, and if you put that thing in the equation, so in the question they gave you this equation, 2x squared plus 3kx plus k is equal to 0. You can pick up any of these values, and if you put them in here for k, then you're going to get a quadratic equation, and if you solve that out, you're basically going to get 2 roots. And why is that? Well, because you initially designed the value of k, so you found the values of k based on this idea. And the idea was that the discriminant has to be greater than 0. And in that case, you would basically get 2 roots. If you solve the equation, you would get 2 roots. So let's say if I take this 2 over here, and I put it in here, and I put it in here, I'm basically going to get a new equation, which is 2x squared plus 3, put the 2 over here, x plus 2, and I'm going to get 2x squared plus 6x plus 2 is equal to 0. And for this equation, I'm going to have 2 roots. Why? Because that's how I designed my values of k. I designed them based on this idea that I need 2 roots. This discriminant has to be positive, which means 2 roots. So if I solve this equation, I'm going to get 2 roots. Now the last part isn't a quadratic problem, but it's just a conceptual problem that I would love to solve. And they've given us this equation, and it doesn't have a value for c. Instead, it just has a constant k. And they say find the set of values for k for which the whole curve lies above the x-axis. So what does it mean to lie above the x-axis? So if you have the x-axis and the y-axis, you clearly know this thing right over here is a quadratic equation, and this is a positive sign. If there's no sign over there, that means we have a positive 1 over here. So it's going to be a smiley face, and they want the entire smiley face to be above the x-axis. Now there's 3 possibilities. Either the entire smiley face is above the x-axis, or it just touches the x-axis, or it touches the x-axis at 2 points. Now in both of these cases, the curve is not entirely above the x-axis. In this final case, it is entirely above the x-axis. So what is the situation? Well, we call it the no-root situation. This is the 1-root situation, and this is the 2-root situation. So in fact, all of this just means the whole curve lies above the x-axis. All of this just means 2 roots. So you're supposed to find the set of values for k for which you have 2 roots. And how do we decide roots? Well, it's this simple idea of a discriminant, b squared minus 4ac. Oh, my bad, not 2 roots, but no roots. No roots. Because your entire curve is above the x-axis, so you have no roots. So it's this entire idea of the discriminant, b squared minus 4ac, being less than 0. Because less than 0, we have negative numbers. And if you have a negative discriminant, that means you have no roots. So how do we solve this out? Well, we put in the value for b, the value for a, and the value for c. Now, b is equal to -6. I found this from the equation over here. And then a is equal to 1. And then c is equal to k. All of this is less than 0. So we can just solve this out. We get 36 over here, and we get -4k. is less than 0. Now you can clearly see this is not a quadratic inequality. It is an inequality, but it's not quadratic because it does not. This constant is not to the power of 2. In fact, it's to the power of 1. If you don't have a power, it means the power is 1. So this is a linear inequality. We don't have to use any quadratic steps for this. So we can go ahead, have our 36 over here, take the 4k over there to the other side, it's going to become plus 4k, and then we can just divide the 36 by 4. So we basically get 4 times 1 and 4 times 9. So k is greater than 9. So anything greater than 9, which is 10, 11, 100, 22, all of these values going up till infinity, basically if you put any of these values in the equation that you had, so the equation they gave us in the question was x squared minus 6x plus k. So if you put in any of these values in place of k, you're going to get an equation that's going to have no roots, or it's going to be entirely above the x-axis. Now, why is that? Well, because you found the values of k, so you found these values of k based on this idea. You use this thing right over here to find the values of k, and this thing right over here means no roots.